Hello students, our next example is turtle in an elevator. We have a turtle having a weight W downward direction and N is the normal reaction force. The turtle is in an elevator. We have to find N, the force exerted on the turtle by the floor of the elevator. We have to find out what is the value of N. Now consider a turtle or simply a person standing on a weighing machine inside an elevator. We are assuming the situation when a person is standing on a weighing machine inside an elevator. There are two forces acting on them. The first one is the gravitational force which acts downward. If we take the vertical direction as positive, the gravitational force acting on the man is W, which is called the weight of the body. W is equal to minus mg, which is acting downward. The absolute weight is mg, which is the positive absolute value. Okay. Now the second force exerting on the body will be the normal force N exerted by the floor on the man or the turtle, which acts vertically upward. Normal force in the upward direction. Now the weighing machine reads the normal reaction force N, which is the apparent weight. What is measured by the weighing machine is what is called N, which is the normal reaction force. Hence, the resultant force on the turtle or the person is N minus mg. This is the result net force on the person. N is the upward force and mg is the downward force. N minus mg is the resultant force, which will be the net force on the person or the turtle standing on the elevator. Now, in this case, we can consider three different cases. First one is the elevator is at rest or moving with constant velocity. When the elevator is at rest or moving with a constant velocity, the acceleration is zero. By the first Newton's law, we know that acceleration of the person is zero. Therefore, the net force acting on the person is zero. In that case, net force on the person is zero. With respect to an inertial frame or the ground, applying Newton's second law, N minus mg is equal to 0 or N is equal to mg. So, the weighing machine shows the result N is equal to mg. This is the apparent weight, which is equal to actual weight of the person. The weighing machine shows exact weight when the elevator is at rest or moving with constant velocity. In that case, N minus mg is equal to 0 or N is equal to mg will be shown, which is the exact weight of the person. This is the first case. Now, when the elevator is accelerating upwards, it has an acceleration upwards. If the elevator is moving with an upward acceleration plus a with respect to inertial frame or ground. Applying Newton's first law, we get N minus mg is equal to ma. F is equal to ma relation. The net force on the person or the turtle is N minus mg, that is equal to ma, where a is the upward acceleration of the elevator. Hence, we get N, the normal reaction N is equal to ma plus mg or m into g plus a. Therefore, the apparent weight of the person is greater than the actual weight by an amount ma, which is the force exerted by the elevator. So, it is greater than the actual weight mg. So, the weighing machine shows a larger value. Weighing machine shows the value N, that is equal to mg plus ma. So, when the elevator is accelerating upward, the person weighs a greater weight than the actual weight. Okay. Now, the third case is when the elevator is accelerating downward. Now, if it is moving with an acceleration minus a, by applying Newton's second law, N minus mg is equal to minus ma. That means N is equal to mg minus ma. Therefore, there is a decrease in weight, apparent weight of the person, than is actual weight, mg minus ma. So, ma is the amount of force acted upon the person by the elevator, which is accelerating downward. Hence, the apparent weight of the person is lesser than his actual weight. So, the weight shown in the weighing machine will be lesser than his actual weight. These are the three possibilities. Now, weightlessness. Here we can find out one particular case, which is the weightlessness of a freely falling body. Now, the freely falling objects experience only gravitational force. That is, as they fall freely, they are not in contact with any surface. That means there is no reaction force to provide for the body. So, the normal force acting on the object is 0. Okay. So, it experiences no normal force. Now, the downward acceleration is equal to the acceleration due to gravity. That is, A is equal to minus G. Hence, the net force will be N minus mg is equal to minus mg, or N is equal to 0 in this case. Hence, the object feels weightless. So, when the body is actually accelerating with a value of minus g downwards, the object feels weightlessness. Okay, for an example, if the elevator wire breaks and when the elevator falls down freely, the person inside the elevator is in a state of weightlessness and it shows 0 weight in the weighing machine. Okay, this is termed as the weightlessness of freely falling bodies. So, freely falling bodies observe weightlessness feeling.